Hello everyone, this is Marcelo from PNCC, and today we'll show you how to manually screen grids using EPU. First, on the TEM user interface, make sure the inventory is done and all loaded cartridges are correctly identified. Next, go to the Atlas tab in EPU and click New Session. EPU will ask if you want to start a new session. Click Yes. Now, you'll need to set a session name. At PNCC, we name screen sessions with the project number, then screening and date. EPU will use this folder to automatically save all the atlas collected in the current session. For the output folder, make sure the Z drive is selected, then click Apply. In the screening task panel, you'll see all slot positions in the autoloader, but only the grids found during the inventory can be selected to collect an atlas. In a regular screening session, we want to collect an atlas for all samples loaded, except for slot number 1, which at PNCC is where we keep our cross-grading grid used for daily alignments. Alright, this green mark tells you what is the current grid loaded into this stage, in this case, slot number 2. To manually screen grids using EPU, we recommend collecting one atlas at a time, and to do so, check the slot number you want and then click Start. As slot 2 is already loaded, EPU will start collecting the atlas right away. This action takes about 6 minutes in this microscope. This area here tells us that the atlas is being acquired, but we cannot see it unless we click in the slot that is being acquired. Alright, now we can see the map being collected. Alright, once the atlas is collected, EPU categorizes the grid squares found based on their brightness and contrast. Similar squares within a set range will be classified with the same color. It's up to you whether you want to use this categorization to help you choose in what squares you want to screen. Within the same atlas, EPU is accurate enough regarding classifying thinner squares with one color and thicker squares with another color. However, these colors can't be used as gold standard classification among different atlases, as they might have substantially different ice thickness, making the characterization of these two atlas being completely different. Okay, let's start screening some squares. Right-click on a square you wish and select Move Stage here. The red crosshair indicates the actual position of the stage. Okay, the stage is here. We can now go to the Auto Functions tab. We now need to find the eccentric height for each square we have selected. You can either request EPU to find the eccentric height by beam tilt or stage tilt. For screening sessions, we usually go for the Auto Eccentric by beam tilt option. Although the Z height might be less accurate this way, it is much faster and it pays the price for a screening session. So, select the option you want and click Start. Okay, as soon as the eccentric height has been found, we recommend to run the autofocus function to ensure your images will be taken closer to the desired defocus. However, for screening sessions, the exact defocus value is not very important, so we recommend running the autofocus function at least once per grid, but feel free to run it anytime you want. So, select autofocus and click Start. For a screening session, the defocus value is usually between 2 and 4 micrometers, as the idea here is to highlight low frequencies, making your particle easily visible. Alright, now go to the Preparation tab, select the Grid Square preset, and click Preview. As the grid square image is acquired, right-click and select Export Image with Overlay. Then, find and open the folder created in the Atlas session. We can see all the folders EPU creates automatically here. Make a new folder with your sample name. Open the new folder created and save this image as Square 1, for example. Now, select the holocentric height preset and click Preview. As it showed while running the autofocus function, this region has crystalline ice. But let's move on with the screening, as not all the users might be experienced to get all the clues. Now, we need to center the stage over a hole, so pick any hole and right-click and move stage here and acquire. From this new image, we can see the stage is over a big chunk of ice, so let's move the stage to a better area. This time, I'll use the option of moving the stage only, without taking a new image. We can see the red crosshair has moved, indicating that the stage is now over a new area. Now go to Data Acquisition preset and click Preview. Cool! That's a good image. As we mentioned before, we do have some crystalline ice in this region, but nonetheless, this image still can provide us with some valuable information. For example, in this image, the particle concentration is good, regardless the ice quality. These white and black streaks indicate the presence of crystalline ice. You can also view the FFT by clicking this button. The ring seen in the FFT is caused by crystalline ice. Now, let's save this image. Right-click and export image with overlay. We can save this image as square 1, hole 1. Now to move to another hole, go back to this grid square preset and EPU will always pop up the last image collected with the selected preset. So this is actually the current square we are screening. Let's move to another region. Right-click and move stage here. We can now center a hole using the holocentric height preset. Click Preview. Alright, we can see this region has also crystalline ice. Maybe this entire square is crystalline. But let's move the stage here, and then using the Data Acquisition preset, we'll take another image. These white marks on the background, that's crystalline ice as well. And by clicking in the FFT button, we have a similar pattern of diffraction spots that indicate we have crystalline ice in this region. And there's no problem at all in having a few crystalline squares on your grid. What really matters is having enough squares with amorphous ice to support a 24-hour data collection in a future session. Okay, switching back to the real space, right-click and export image with overlay. We can save it as square 1, hole 2. Now go back to Atlas tab and let's check another square in a different region, cause maybe the adjacent squares around here are also crystalline. Alright, this square seems nice. Right-click and select Move Stage here. As soon as the stage is ready, the first thing we need to do each time that we are visiting a new square is to find the centric height for that square. So go to Auto Functions and select Autocentric by Beam Tilt and hit Start. Alright, this is optional now, but let's perform the autofocus function as well. Okay, now go to the Preparation tab, select the Grid Square preset and hit Preview. We want an image from the current square we are visiting. Cool. We can save this image as square 2 and select the holocentric height preset to accurately center the stage over a hole. To do that, right-click and move stage here, or move stage here and acquire, either way. Now using the Data Acquisition preset, we'll take a new image. Great. We do have some transient contamination here, but we do not have crystalline ice, as highlighted by the absence of ice rings or spots. Let's save this image as square 2, hole 1. Okay, let's select the Grid Square preset and move the stage to another region. Right-click and move stage here. Using the holocentric height preset, let's update this image by hitting Preview. Now we can accurately move the stage over a hole. and we are ready to take another image using the data acquisition preset. Nice. We have some particle overlapping here, here, but that's still a great image. Let's save it as square 2, hole 2. Alright, in case you want to record the locations of the grid squares screened, you need to go back to the Atlas tab and export an image having the stage over the grid square screened. Then you can save this image as atlas_square2, for example. We know the first square screened is within this region, and you can always go back here and find the square, or move on. Okay, at PNCC we usually screen 3 squares, and ideally with different sizes and at different regions of the grid. It might seem counterintuitive at first, but maybe your particle might prefer thicker ice. So let's find our third and last square, and now we're looking for a thicker one. Alright, this square might have the thickest ice compared to the squares screened previously, as it appears smaller than the squares we have visited before. So right-click and move stage here. Let's navigate to the auto functions and find the Z height. And this time, let's skip autofocus, as we did previously and is optional now. So go to the Preparation tab and take an image using the holocentric height preset. As we can see, we are already over a hole, so go to the Data Acquisition preset and click Preview. Nice! We have some transfer contamination, but there is no problem here. So to save the image, right-click, Export Image with Overlay, and we can name this as Square 3, Hole 1. Okay, again, to move to another hole, we'll go back to Grid Square preset, and this time we'll hit Preview, as this image belongs to the previous square and not the current one. Alright, let's move the stage here, then select Holocentric Height preset and Preview. Then center the stage over a hole. Select the Data Acquisition preset and hit Preview. Okay, let's save this image as Square 3, Hole 2. Now we can go back to the Grid Square preset and save the image of the current square, which in this case is the Square 3. Additionally, if you want, we can save the location of the last square screened by right-clicking and Export Image with Overlay. This is the first square we screened. Although that's optional, you can move the stage here and save this stage position at any time. And that's it for this grid. Now we need to select the next slot we want to screen, for example, slot number 3, and hit Start, as for a screening session we expect to access the quality of every grid in order to prioritize them for a future data collection session. Alright, thank you for watching our video. If you found it informative, please like and subscribe. Comment below with any requests for videos and any questions you have, and we'll be happy to answer them. See you next time!